Okay, hello everyone. Thank you for joining us today. Before we get started, I just wanted to remind you that everyone is in listen-only mode, but you can ask questions anytime in the Q&A panel. We'll have a few minutes at the end of the webinar to go through all of the questions. So in our previous webinar, we discussed about the rise and fall of segmentation in pricing. Well, today, Dominic O'Regan is going to expand on this topic, and he's going to look at the advances of generative AI and how it impacts price optimization. So as I mentioned, your host today is Dominic O'Regan. He's a senior strategic consultant here at Pros, and he's been working with companies for 15 years in pricing, helping them improve margin and revenue performance through the implementation of price and sales optimization. With that, let's just jump into it. Dominique, the floor is yours.
Fantastic. Thank you, Malika. So as Malika mentioned, we started looking at the rise and fall of segmentation in pricing, right? And we began to understand and perhaps discover, while it had some advantages, it maybe has come to the end of its run, and it's no longer perhaps the best way forward, right? So we sort of saw the dawn of pricing segmentation, and now we're looking beyond its destruction as well. Just to kind of really briefly summarize some of what we looked at previously, some of the problems that we identified with pricing segmentation. So some of the problems are really obvious, right? So things like clustering and bucketing, a clumsy mechanism by which you stick stuff together and pretend it could and should be exactly the same, even though it's not really. They're just more similar, perhaps, than some other things. Maybe not even that, but we'll come back to that. The challenge of data sparsity that segmentation creates when you begin to focus in on just one set of circumstances, customer size and geography, and then you start to find that you have not enough data, perhaps, to learn anything meaningful from it. You know, one of the big challenges is that segmentation models aren't designed to look across the whole data set and to learn from the whole data set and apply it in each and every situation. We looked at the sort of accuracy versus opportunity, or how you can cheat, how you can scam a segmentation model. So that's the idea that when you have a small number of segments, your model looks like it sees a big opportunity to improve price, because you've just got a lot of things in the same group that aren't the same. So therefore you'll see more range of prices, and the model thinks, woohoo, there's lots of money to be made. It's not true, right? Or on the other end of the scale, you have too many segments, you get that sparsity issue, or you simply get one transaction in each segment, and you can't really learn a lot about how to price one situation from one previous record, right? And that they are fundamentally limited in the way that they understand the data to your historical scope, the way that you have been pricing in the past, right? They're not really able to properly leverage a how can this be improved for the future concept, because it's stuck within that segment, if you like. Okay, and that's just the beginning of some of the issues. The conclusion that we came to, I hope you agreed, is that segmentation, it's not horrendous, it's not terrible. It was a good idea when it was the only thing that was available. It still has some really useful applications in pricing. It's a nice lens through which to think about things like our basic price waterfall structures. It's a nice mechanism, a little bit limiting, but it's a nice, easy mechanism to get started in terms of understanding and analyzing overall performance and things like that. But that it is now a horrendous idea when it comes to price optimization. Yes, it was a step forward, but it was a small step forward, and we can now live in a world that is a giant leap ahead of what segmentation was able to deliver for us. So today we're going to look at the dawn of what I'm going to call real AI. Now, segmentation and other approaches were a form of AI. I'm not, I know that. But when I think about how we think about AI today, we tend to think about environments that are able to find, derive, and deliver information that we wouldn't otherwise have been able to collect and get to ourselves, right? And so it's in that context of that future AI or generative AI as is appropriate here. So you could say, well, why bother? I mean, that segmentation thing, it wasn't perfect, but it was okay. It gave us a step forward. I mean, that's great, isn't it? Lovely. Except that we live in the world of pricing, and for pricing professionals, okay and a bit better and better than nothing aren't really accurate enough. They don't cut the mustard. I don't know if that phrase translates very well. Another way of thinking about it is, if I need to stand behind my prices and I need to project confidence to the rest of the organization and the sales team especially, that what I'm giving them is something that they really can achieve, okay, and maybe a bit better than what we had before, doesn't give me the confidence that I can then share and express to everyone else that will lead to success. So I teased you with the idea that there was this generative AI things, a bright new future, right? And so today we're going to look at what that might look like, or what it does look like, in fact. But to get us started, we need to go back in time a little bit, right? We need to think, where did this generative AI pros, neural network, deep learning thing come from? Why on earth have they come up with this? What were they thinking, right? So if we take that little step back in time, then somebody in our pricing teams or our science teams, maybe it was our chief pricing strategist, maybe it was one of the guys in the science team, I don't know. Anyway, somebody at some point said, what about all this new AI stuff? What about these deep learning networks? Maybe they were being tasked with the next iteration of improving the current segmentation based price optimization, and maybe like the Formula One car that's been adapted all season, and you've got slightly better and better performance, but then over the winter somebody creates a whole new car, a whole new platform that can then be generated. Maybe it's the same thing. Maybe they were just looking at it going, I don't want another teeny improvement on this idea that's not brilliant. Somebody said, what about these deep learning networks? And so what we did was to create some prototypes, right? So we wondered, is this going to work better than segmentation-based AI? And so we created some prototypes and we tested it with real pricing data. So obviously with their permission, we took some customers' data, some customers that were using really good segmentation-based AI. And we built some models. We built some models and we had a look at what happened. And we were absolutely flabbergasted, stunned, amazed, if you like. I couldn't find a picture of our chief AI strategist looking stunned, so I drew some exclamation marks on his head. But you get the idea. The difference, the improvement in accuracy, the opportunity that it meant for those data sets that we were looking at was so phenomenal and so staggering that we had to start moving towards, right, this is something that we have to turn into a product and we really have to leverage. So if you remember, this new hope of generative AI in price optimization means we get rid of that segmentation thing. Gone, dead, ancient history, dinosaur, right? We get rid of bucketing. That doesn't have to go just because segmentation goes, but we certainly don't want that. That is one of the big issues of segmentation. You've got to bucket things. Terrible idea. Let's get rid of that as well. Let's not have large, medium, and small customers. Let's just have customers and exactly how much do they spend with us. We want a model that is leveraging big data. Segmentation models are not leveraging big data. They're grouping things and dumbing it down, and they can't take anything you want to give it. We want a model that can leverage any data and any attributes that we can find. And of course, the main reason we're doing this is because we want a phenomenal increase in pricing accuracy. Now, along the way, it turned out that we also got all sorts of other great freebies as well. By doing this, we created an environment that can tell us what is driving price response, where we can, for the first time, optimize prices for configured or engineered to order products, for services, for project business, even for new products. And that's really difficult to understand. And by new products, I don't mean, I don't know, maybe we're a business that sells, I don't know, flow control valves, right? It doesn't mean that their data can suddenly tell them how to price a hammer. But if we are in thinking about, we're a company that sells hammers, and I have a stronger hammer and I have a measure of strength in my data, I can then expect the AI to tell me if I develop an even stronger hammer and I can measure how much stronger it's going to be, then the AI can tell me exactly how much value I can capture, what the price would be for that new variation of a product. Another broader way of thinking about it is that we can price accurately in completely new situations. Places where we've never sold those products before, types of customers that have never bought that type of product. Okay, so should sound good, right? Maybe it sounds too good. I mean, what's the catch, right? This sounds too good. Why wouldn't we do it? Why isn't everybody leaping on it immediately? Probably because everybody doesn't know about it yet. But well, we do have to think about it, right? We've created an environment that's using a deep learning network. So is this something that you can control? Can I understand it enough to be able to explain it, to be able to control it? Fundamentally, the real question is, can I trust it? Do I have enough information to be able to trust the numbers that I'm getting? Put another way, is it a black box? Is it something where I can't go to the CEO and say, I've got this new plan in our pricing team. We're going to introduce this pros neural network thing, and it's going to generate brilliant pricing for us, great numbers. We're going to capture more value, more margin. How does it work? I don't know. What does it do? I don't know. It doesn't work, does it? Nobody's going to sign off on that. So we had that prototype, we had those results, and then what we worked on was creating the product, and the product needs to go way beyond a black box. The product needs to be explainable AI. So I'm going to give you a little glimpse into the pros guidance application using the deep learning networks, and we'll kind of step into and really focus on how do we deliver those more accurate prices in an environment where you have not just control, not just explainability, but it actually improves on the control and explainability that the segmentation models created. I don't think we were expecting that when we first went down this journey, that you would actually get more understanding rather than less understanding from a complex deep learning network. Okay, so we kind of need to look at a few aspects of that kind of explainability. But if we take one step back and remind ourselves as to what we're trying to do, we're trying to price a situation. And you will have seen this slide on the previous presentation if you were there. But essentially, we're looking at a given situation, which you could express through a sentence, and we're saying we're trying to generate the right price for this situation. So a particular type of customer of a certain size buying a product in a certain location that tends to buy a lot or not, and so on, right? And each of the colored words in the sentence are an attribute, something that might be influencing the price that we could or should be able to achieve, and the prices that we have been achieving in the past, right? So one more brief dig at segmentation. Segmentation is a bit like looking at the world through a straw. You only see a small glimpse, and you're trying to price that situation based on that little bit that you can see. And we want to move beyond that, right? So in those terms of those attributes, right, we've got that list of attributes. We've taken that sentence and we've said, right, that's a list of information that we're going to use now for our pricing, right? And you can see the customer size is large and so on, right? So in a segmentation approach, there you go, there's your answer, right? The price for this thing is €34.56. Okay, where did that come from? It came from because it's a large customer, because it's a convenience store, because it's in this location. Yeah, but how much of that price was because it was convenience? I don't know, it's just that convenience people tend to pay that. Oh, okay. Did that ever really explain where the 34.56 came from? Not to my mind, it didn't. So when we think about what we can do with a deep learning network, we start to get a very different picture. So firstly, Let's get rid of that 34.56 for a moment, because it's probably wrong, because it was based on segmentation. Let's change the large customer to exactly how much do they spend with us. I don't want them to be the smallest large customer or the largest small customer and not know what that means. I want to know exactly how much they spend with us. Okay, so now we've got a similar situation. We know exactly how much. We've still got a price, slightly different price, better price maybe, but we can take that price and we can break it down. And we can say precisely how much of that price came from the fact that they are spending. This spend is actually quite a lot for us, and therefore we are typically selling, and we need to sell at a significant discount from our average because of the size of the customer. Because they're a convenience store, they tend to pay a little bit more on average, and so that brings it back up a little bit. We can specifically measure and explain exactly how each attribute influenced the price that we're delivering. Now, probably if you want to share that with the sales team, you don't want to give them a whole list, give them the top few, but that's what the engine is able to do. And it's not just an idea, it's not just an engine, it's a product. It's a capability that we have today. Our pros customers using guidance can receive recommendation, and they can view information like this that is showing them and measuring precisely which attributes have influenced the price and how much those attributes have influenced the price. So going from left to right, biggest influence down to least influence. That's an amazing step forward in explainability, but it enables something else as well. It enables you to start thinking on a broader basis about how much do those attributes influence all of my prices. You can start to stack rank the attributes and say, well, actually, for this business, the most important thing is how often people buy. That has more influence on what you can charge than anything else. That may or may not be true for yours. Your business will be a completely different ordering. You might even find that the ordering is different for different locations, right? If I look at one country versus another, it might be something else that's the most important characteristic in terms of the price I can achieve. You can start to understand what is driving price performance at any slice of the business. And if I take one of these attributes, so for example, the channel maybe, then for that individual attribute, I can start to understand its influence. So in this particular picture, we can see that our distribution channel tends to sell at a premium to our direct channel, right? So you might look at that and go, wow, well, I could work that out anyway, right? I've got a distribution channel. I know it makes more money, more margin than my direct channel, right? Okay, but what you don't know is whether that's because it's distribution or because it's direct. What I mean by that is, it might be that your distribution sells at a premium, right? But that could be because distribution only sells to a certain type of customer, and it's the type of customer that actually means that you get a premium. Or distribution is used in countries that are selling at a premium to the countries where we have direct channels. How much of it is really down to whether it's distribution or whether it's direct? So this is having removed the influence of everything else. This is information that you cannot get to today, but certainly not easily. And again, across any slice of the business. We're beginning to explain more than just the prices and where they came from. We're beginning to be able to understand how things are working. So let's move on to another area of explainable AI, which is one that salespeople love, right? You're giving me a price. Just give me some other price. Show me what other people are paying. Show me similar situations, similar transactions. I'll believe you when you show me that people and situations similar to the one that I'm pricing are achieving similar prices to what you're asking me for. So here's the segmentation approach. It's not terrible. It's actually quite easy to understand. Let's imagine that this grid represents different customer sizes. So small, medium, large, left to right, and maybe top to bottom, I don't know, order size, right? So right in the middle is my medium customers with medium order size. And I've got that little white dot, which is my recommendation. So this is the one I'm pricing. Here's my price recommendation. And what you can do is you can say, well, okay, Mr. Salesperson or Mrs. Salesperson, here are the similar transactions, right? And they are reasonably similar, but the dot we're pricing is in the corner. It's the very smallest of the medium, and it's the very largest of the medium-sized quotes. And I'm going to include the very biggest of our medium customers and the very smallest quote size of the biggest medium customer as a suggestion as to support it. If I was a salesperson, I'd smell a rat if I was given that. So what we can start to do is a different approach. Let's take that grid and let's get rid of those stupid segmentation lines, right? Let's stop destroying our data with those concepts. Now, we're only working in 2 dimensions here, but this would be across, in reality, 10, 20 dimensions. I don't know. Okay, 2 dimensions, we can picture it. Let's get rid of those segmentation lines. Remember, segmentation bad, in the bin. We've still got our dot. So now we just look at, well, what are the transactions that are most like this? The ones that are closest in actual revenue to this one. The ones that are closest in actual order size to this one. They become our suggestions, and we are delivering to the salespeople more compelling examples, more similar real transactions. Once again, that's something that is within our product capability. This is the view for the pricing team. Obviously, view for sales team, a little bit easier, a little bit simpler. But we can show you a price recommendation, and we can show you the most similar transactions to that price recommendation, those that are nearest across all of the different dimensions, right? Again, getting that explainability in place. So the third aspect to explainability is actually the win rate concept, right? So when your learning network has created a price recommendation, what it's able to do for every single price recommendation, having learnt from the entire data set, is work out for this price recommendation for any given price. So think of the x-axis as price, and the y-axis will change in a moment anyway. But for any price or margin or discount or whatever it is, we can predict what that win rate is going to be, right? How is another question entirely, but we'll come back to that. So we can predict what that win rate will be. Now, having predicted what the win rate is, we can look at what the margin or revenue or volume performance would be for that win rate, right? You can just multiply the 2 and work out where the absolute sweet spot is, right? Win rate times price gives you that margin curve, if margin is what you were looking for. The top of that margin curve, that's the perfect price. By definition, if what you want is maximum margin, right? Pricing anywhere else is not a good idea, because the win rate suggests is too high a chance of losing it, or too high a chance of winning it at not enough margin, right? So that's the sweet spot. That's what we're looking to target. And once again, that is part of our product capability. So we might present simple things to the salesperson, like here's your target, and here's the start and the floor and stuff like that. But for every single possible price recommendation, whether it exists in the past or not, we can predict those win rate curves, we can calculate exactly where the sweet spot is, and work out where to capture the maximum value. One of the hidden truths behind segmentation approaches is not the segmentation itself, but when people talk about win rate or elasticity in a segmentation world, what they're normally really talking about is a demand elasticity, which is really not the most appropriate model for most B2B situations. We're going to win or lose this whole deal. We're not going to drive more demand by my negotiated price for this customer. We're going to win it or we're going to lose it. And that's why win rate elasticity and the win rate concept is really key to this working well, and for us capturing the maximum possible value for our customers. Right, I was racing through that to try and get to this point where we can do questions and answers as quickly as possible, because I tend to run out of time, and there are more topics and more depth behind this that we might look at in follow-on sessions or whatever else. But let's see if there's any questions ready.
Yes. All right. Well, thanks a lot, Dominique. That was actually very clear and insightful. So thanks for this presentation. So we do have a few minutes for Q&A, and I do have a few questions. Please feel free to drop any additional questions in the Q&A. We do have a bit of time to address them. So I have actually two questions on data, and I'm kind of tempted to combine them for you.
Hmm.
You let me know if you want to answer them at once. But the first question is, how does these models cope with poor data quality? And the second one is, do we need a data science team to use this? I think they kind of go a bit
Okay,
together.
yeah, they sort of coexist, don't they? So data quality is always a consideration, right? In any situation. One advantage of this approach is that data quality is less of an issue. It certainly isn't something that you can completely ignore, um, but with a learning network, so think of it this way: when you think about a segmentation approach, if your segment contains your poor data, if you've got 5 transactions in your segment and 3 of them are completely wrong or whatever else, it's very, very difficult for anything to learn what is the correct answer for that segment. When you have a learning model that is learning across the entire data set, and it's a bit like the way these things learn is that they try to do things and they try to succeed, and then every time they feel like they got it wrong, it's like they give themselves a bit of a smack and go, right, okay, naughty, start again. And it's like they're punishing themselves whenever they get it wrong, right? So whenever they come across bad data and it damages their prediction, then they punish themselves by going, well, I need to do that again, and what I've learned is I need to ignore that data item, right? So it's not true to say you can just give it any old rubbish data, but it's certainly more stable and can cope with a lower data quality than a segmentation approach can. Um, in terms of data scientists, and sometimes people that have read up a little bit on AI will think about things like what's called feature engineering, which is where you take a data set and you say, can I change that in a way that the AI will better understand? And certainly that is something that is worth thinking about as you start a project. But what we find is that almost all of the time, you can have a very significant, very accurate model that is a huge step forward without doing any additional feature engineering on the data that you have out of the box. And that's partly because the models are robust and can make a really good quick start, partly because we do a little bit of automatic feature engineering, things like calculating annual revenues and stuff like that. So there's an element of that that's done as part of the process of setting up the system anyway. And then what we tend to recommend is that if there appears to be an area of data that might be interesting or an idea, that we might look at testing that and adding it over time. So we don't try to slow down the ability to get the big value by having to have a sort of a feature engineering or a data science project alongside things.
Okay. Okay, I have a bunch of questions. So the next one is this approach valid for B2C and B2B customers, or you don't even start this segmentation?
Yeah, so what I would say is the the model that I've explained today has been focused on the kind of the win rate element, and the win rate element is most applicable in a negotiated sale B2B type environment. The segmentation is still, not a brilliant idea in any situation, but the mechanism I've used today to explain things is very much the B2B context of negotiated sales. In the B2C context, that's where the elasticity model is probably a little bit more demand based, volume based, right? So I'm setting a price that is going to be visible for a group of customers rather than an individual negotiation. And I do expect my price to influence the demand and the volume that I pick up overall. So that's the real difference. It's more a different flavor of the model than is the model applicable or not. Yeah.
Okay. I want to squeeze in one last question.
Mm-hmm.
What is the impact of limited data slash large variance slash white spots in the dataset on the model?
That sounded like 3 questions. Can we read it again? Let me.
It's what is the impact of limited data and
Yeah.
large variance and white spots in the dataset of the model?
Okay. So limited data. Um, often people are referring to situations where they don't have a lot of transactional volume. Um, and the simple answer to that is we have to look at it to know whether or not there is sufficient data volume to be able to fuel. Is there enough information to learn how to predict things? And that's a combination of the number of transactions or whatever else it is that we're kind of fueling the model, and also the data available. Does the data that's available actually explain the price variation that is present, right? So sometimes that just means that we need to have a look at a company's data with them and work out whether or not it's a good fit and it would work, and maybe test a model and see what sort of accuracy it's able to derive. Um, um, the other parts of the question seem to be referring to what about sort of gaps. So I don't know, maybe I've got data for certain countries but not for somewhere else, and so on. And again, the easy answer is, well, just test it, see what it does, right? But in the main, it's very good at filling the gaps, because what it's doing is it's learning from the entire data set what the influence of, let's say, I don't know, let's say you've never sold a product family in a country. Simple example, right? But you have sold it in other countries and you have sales in that country. And so what the system is able to do is to understand how to bring those influences together to work out what the right price recommendation would be for that product family that's never been sold in that country before. If it knows everything else, if there's enough other information for it to understand that from the whole data set. And again, that's part of the value of looking at the whole data set whenever you create price recommendations, right?
Okay. Well, thanks a lot. We are over time, so thank you for sticking around. We do have a lot of other questions that we could not address, but we will get back to you by email.
Mm-hmm.
So thanks again, Dominique, for this great session. And thanks, everyone. I wish you all a great day.
Nothing excites me more than getting some data and having a look at what the model does. So
You know?
just reach out to us. Let us have a look.
Yes. Thank you. Bye-bye.
Thanks.